Hello students, Miss Slyman here, and in this video I'm going to talk to you about kinematics. So kinematics is the study of position, speed, acceleration, and we're going to do that by looking at this lovely ladybug. So she moves along a branch. Position from the trunk of the tree is given a time t with this equation. The distance is measured in yards and t is measured in minutes. So the first thing I'm asked to do is find an equation for the velocity of our ladybug. Well, we know velocity is going to be the rate of change of position. So that's going to be s prime of position to give me velocity. It's a nice easy polynomial. So 2t minus 6 is going to be my velocity graph. And this is from 0 to 5. So I'm going to graph it from 0 to 5. So at 0, of course, we've got negative 6. And then my slope is 2. And so we're going over to 5. 1, 2, 3, 4. So let's actually go over to 5. I'm going to put in my line. And really, I'm going to make a line segment. So I should have ended that right at 5 because that's where I'm measuring from. And this is my velocity. Here's my time being measured in minutes. I also want to think though about my position of my ladybug. So this graph that equation factors. So s of t is also t minus 5, t minus 1. So I know I have x-intercepts of 1 and 5. My initial value is 5. My vertex is going to be halfway between, so that's when t is 3. So at 3, I get negative 2 times 2 is negative 4. So I can make this graph. So I've got part of a parabola there. And again, I'll stop at 5. So here's what my ladybug is doing. She's starting away from the branch, 5 yards away, and she's crawling back towards the trunk. At this point here, her position is 0, so she's at the trunk. Then she goes past the trunk down another branch to the left. At this point, she turns around and starts going back towards the trunk, and she ends up on the trunk at 5 seconds. So let's make a little tree over here. So here's my trunk, and I've got some branches. Let's do, okay, so when the ladybug starts, she's 5 yards away from the trunk. So here's my ladybug, I'm gonna put her there, and then let's label that as 5 yards out. And so what's happening is that she's walking this direction. At 1 minute in, she's at the trunk, and then she keeps walking that same direction she was going until 3 minutes, and then she makes her furthest distance, which is 4 yards this way. So if I was measuring the distance, I would say it's 4 yards, but we know it's 4 yards to the left of the trunk. So here's my 0 point. Then the ladybug decides to turn around and heads back this way, and at 5 minutes, she's back at the middle of the trunk. So let's come down. So my negative velocity, well, if I look at my velocity graph, I see that it's negative in this region here. So I'm going to make this a darker blue. So my velocity is negative up until time 0. So in this area, that negative velocity is when the ladybug is walking back towards the trunk and then further past the trunk. So velocity less than 0 tells us that the ladybug is moving left. The positive velocity, that's this region. So this negative velocity was for 0 less than or equal to t less than 3. My positive velocity is when the ladybug is going right. I don't know where she is as she's going right, because remember, she was going to the right all in this area. So I don't actually know where she is in relation to the trunk because my velocity is positive. I just know she's moving towards the right. So that is for times 3 to 5. The ladybug is at rest. Well, remember, our ladybug started at 5 and then was here at 1 minute. She was at the trunk, so her position was 0. Got down to -4, so she was 4 to the left, and then she turned around. Well, so this moment here is where she was at rest. Here she's at rest. I've got a horizontal slope. Because it's a horizontal slope, my velocity is 0. So v of 3 is equal to 0. So t equals 3 is when the bug is at rest. Okay, so now at t equals 1. Well, t equals 1 is this point here. T equals 1, my velocity is -4. And v of 1, so we just said v of 1 is -4, and that's going to be yards per minute. So in the context of this problem, this means that the ladybug is going left at a speed of 4 yards per minute. Notice I don't say -4 here because the negative is accounting for her going left. And now thinking about speeding up or slowing down at t equals 1. Well, at t equals 1, we have this point here. I also know my acceleration is the slope of velocity. Acceleration is how velocity is changing. So looking at our equation here, the derivative of velocity is acceleration, which is 2, and it's positive 2. What that means is it's like I have a wind over here pushing towards the right at 2 yards per minute squared. So that's my units of velocity. So if you think about this, it's a constant 2. And let me be thorough and add in my units. So that's yards per minute per minute. So yards per minute squared. It's how my velocity is changing every minute. So this ladybug is starting by walking this direction. And she's going at a pretty quick speed. That's when she's going 6 yards per second. But then her speed is decreasing, and that's because she's trying to walk this way, but the wind is trying to push her towards the right. So even though she's walking towards the left, the wind is pushing her. So she's walking to the left, but she's getting slower and slower and slower because the wind is in her face, pushing her, until at this point, when t equals 0, the wind is so much that now she's being pushed in the other direction. But now the wind's at her back, helping to push her, so she's getting faster and faster and faster this direction. And I can see that because it's getting steeper and steeper. My velocity is increasing. So at 1 second, her velocity is -4 yards per second, but she's slowing down. So she's slowing down because her velocity, and that's at 1. So the velocity at 1 is negative, and the acceleration at 1 is positive. So that's how I know she's slowing down. I'll leave you to think about this worm, and we'll discuss it in class.